everyone. My name is Nuño Basurto, and I'm from the University of Burgos, and together with the University of Coruña, we have made this work. It's entitled Dimensionality Reduction Methods for the Analysis of Web Traffic. First of all, here we have the outline. First, we are going to start with the introduction. And first of all, the main motivation of this research is about one of the usual targets of the attackers or hackers, as you wish to call, are the websites. But in this way, a scan detection has been paid to the unsupervised learning, and specifically in the projection methods. So we have focused the research in the use of projection and dimensionality reduction methods to a data set about attackers of the websites. We have applied different methods. The first of all is the Laplacian eigenmaps. This method tries to preserve the local properties because it tries to minimize the distance between these neighbors. I mean, between the end instance and the neighbors, but on the other hand, it maximizes the distance between the non-neighbor instances. In the same way, isomap algorithm constructs a matrix with all the distances between the points as Laplacian eigenmaps. But in this case, it estimates the geodesic distances between the matrix values and then perform the dimensionality reduction scaling the values of the matrix. On the other hand of these methods, we have here the T-distributed stochastic neighbor embedding, TSN, and this is a non-convex technique. It always tries to reduce the points who are placed together in the projection. This is made using the probability distribution of a point with its k-inverse neighbors, and then trying to reducing the dimensionality, and then it optimizes the dimensionality. Okay, it's a little hard to explain. But then in the images, we will be more easily to understand. The last of the methods used in the research has been the Bayesian learning. This uses an artificial neural networks, and the main point of this method is the beta parameters, who is used for the weight update process. Then it's updated the learning rule of the probability function, the PDF, of the residual with the dataset distribution. Here we have the dataset. It's called CISIS 2010 second version, and it simulates the attacks produced in HTTP queries. One of the big majority of the attacks normally are the DDoS attacks. So in this way, we have worked with the length of the queries. And this dataset was really dirty or mess because there were a lot of repetitive information. There were more than 200,000 instances with similar information. So we decided to group these instances into a group of sessions. In this way, we reduce the quantity of the instances from 200,000 to no more to a little more than 10,000. And we generate new variables that are not in the beginning in the dataset. For example, method, payload, and URL. First of all, I'm going to explain the payload. And this variable, it's in the shape of a key value. For example, in the down part of the slide, it's possible to see some examples. For example, in the session, we have modo A insertar, precio 1,764, and so on. So in this way, we try to make dummy variables because there are 19 types of keys, like precio, and the part of the value, like insertar, we just take the length. This is so important in the way of the DDoS attacks because it's normal to make a really large values in this field. The other variable is URL, and here we have work taking a normal URL. It's something the example of the down part of the slide, and here it's possible to see how there are different directories like tienda uno or público, and finally always there are some extension like GP8 or GIF or so on. So we made a count of all the directories using the crossbar. In this example, for example, we omit the part of the localhost 8080, and we would take just two, tienda uno and público. And for the part of the extension, we just make dummy variables, independent in the case, GSP, and so on. So finally, we generate two new data sets. From the original one, as I said, is really large. There are a lot of samples, a little amount of features. And joining the sessions, we just get 13,000. From this point, now by processing the URL and the payload variable, we get 50 and 78. So now, why we make a dataset 1 just using payload and D2 just using URL and payload? Because we have a little afraid about the noise of the URL variable, because it makes a lot of noise. In the beginning, we started to analyze, and we see a lot of noise. So we decided to work with two different data sets. For the results, first of all, we make a normalization 0 to 1, and we make different combinations of parameters. In the case of Laplacian eigenmaps, we put a value of Q12. The same in the case of isomap, and in the case of TSNE, we use a perplexity of 155 and the theta of 0.5. Now, in green, it's a little hard to see, but we have the normal instances, and in red, the anomalous instances. Okay. The main problem of this dataset it was that the majority of the instances are from the anomalous class, and the minority was the normal class. So it was something like different, just cross the normal topic. But now it's possible to see how the green instances are, in this case, focused together in a similar point space, and in the case of isomap, similar. But although it can appear that there are a large quantity of anomalous instances out or isolated from the normal, in the reality is that the majority of the instances of the anomalous class are was really at the same place of the space. So in this way, we tried to the TSNE because it's a completely different method. As I say, it's not non-convex. So we decide to let's see what happens in this case. And here we can see a cloud of points of abnormal and anomalous instances together. Maybe in the case of TSNE, it's possible to see how there are little places isolated, but it's in the case of the behavioral learning, BHL, where most of the anomalous instances get isolated from the normal. Although there are a big quantity of both instances together. In the dataset 2, we see the similar problem. In this case, in the Laplacian eigenmaps, the normal and the anomalous instances were more together around this bar. And in the case of the isomap, there are two groups of the normal instances instead of one, that in the dataset 1. I can remember that this dataset has more variables than the other one. So then we tried with the TSNE again, and here again or worse, that in the dataset 1 we have more isolated places, but here no. Here they are just a little bit out. And in the case of the behavioral learning, we get a really similar result than in the dataset 1, with a big amount of points together in the down part left. And in the top part, the majority of the anomalous instances are isolated, although there are some of the normal instances with the rest of the anomalous. So here, after this study, we conclude that BHL is really better than the others, more taking into account the Laplacian and the isomap. But we also thought about, BHL can contribute in this kind of dataset, but not at all taking in this dataset in concrete. Okay, we assume that this tool is interesting to take into account in a future studies with this kind of datasets, but not in concrete in this one. We didn't get good results or very remarkable results. And on the other hand, generating more instances don't improve the visualizations, just a little bit in the case of the BHL, but in the case of Laplacian or isomap or TSNE, we get really similar results, and we get really worse times of execution time, because at the end we have 29 more instances, variables, sorry. So it was computing, it got a worst result. As a future work, maybe will be interesting the application of another visualization methods out of the kind of the convex, like isomap and Laplacian, and maybe focus more in methods like behavioral learning, which use artificial neural networks. Maybe it can improve the results in contrast of this first one. Maybe also combining with another machine learning models, but we have very clear that in the context of the preprocessing, it was impossible to get more, because this data set doesn't have enough information. It was really impossible to get more information and more instances and so on. So maybe combine with, maybe try with supervised learning, and obviously we would like to test the BHL and these methods also in a larger data sets in the context of web traffic, But so overall, taking out the VHL because it gets good results, but maybe the rest of the methods used in this research are not enough for a larger data set, taking from the point of start this research. So thank you for your attention, and I'm here for answering your questions.
Thank you very much. It's a very hard field, I think, cybersecurity, because the data sets usually have a lot of samples of malware or attacks and so on, so you don't have the good information, and also the bad information is very, it presents a huge variety, so it's hard to find the useful information. So you have chosen a very hard...
Yeah, about this topic, there are 2 or 3 data sets which the people have used constantly, and it's impossible to make nothing novel with that kind of data set, and we try to use not a novel, but a different, because for example, this is just from Spain, maybe the international researchers have not used in the same ways, like in this one, but it's really hard to work with this kind of data sets.
Yeah, and the thing is that you have to analyze it, but you want to keep it in real time in order to be able to detect something useful at the time that should be. So it's very...
Yeah, this is something complex. Like when in the beginning the people say, yeah, the 80% of the effort of the data science has to be made in the pre-processing. Yes, in this case, yes, or maybe more than 80% of the effort.
Yeah, that's true. Are there any questions for the speaker? No? I would like to ask if you have tried these methods in a different data set before, or what was the reason in order to...
Yeah, we tried this kind, but in another kind of data sets, like it was in the beginning of my PhD doctoral thesis, and they get good results. Overall, the TSN and behavioral learning, they get really good results. My dataset was based on robotics, and there are a big distance between both kinds of data at the end. But yes, we try there, and we get good results.
It's very interesting, reducing the features in order to then only analyze just the more important ones and try to decide if something bad is happening. But
yeah, in this case, yes, something was really bad. But our proposal was that behavioral learning it's okay for working this kind of dataset. Yes, in this one, no.
Okay. Thank you very much for your explanation.